Good afternoon all. Am I audible?
Yes, ma'am.
Okay. So last lecture we have seen what is lattice and what are the different properties of lattices. So have you remembered? There are four different properties. Those are satisfied by lattice. What are those properties? Yes. Have you remembered any property? Okay, so for this lattice, we have seen there are four different properties satisfied by lattice. First one is idempotent, then commutative, third one is associative, and last one is absorption. So we have seen proof for each of these properties. Now, today we have to start with the next point, that is lattices as algebraic systems. So a lattice is an algebraic system and that is denoted by L star XOR with two binary operations star and XOR on L, which are both commutative, associative and satisfies absorption law. So in this way we can represent lattice as an algebraic system. So in the unit number 6 we have seen what is algebraic system. So here lattice is an algebraic system and that is denoted by L star XOR. So L is for lattice, star and XOR, these are two binary operations. That is, first operation is meet operation, second one is join operation, or we can say that this is greatest to lower bound and this is the least upper bound. So these two operations are defined on L and these two operations must be commutative, associative and it should satisfy absorption law because these are the some properties of lattices. So now we have to write explanation regarding commutative, associative and absorption law because here we have written that these are the properties satisfied by these two binary operations. So let us take first property and that property is commutative property. So we have seen what is commutative property. A star B is equals to B star A. So if you consider any two elements A and B, those belongs to L, then we have to show A star B is equals to B star A and A XOR B is equals to B XOR A. So this first operation is meet operation, second one is join operation. Just a minute. So we have to show this proof. Last lecture only we have seen how we can prove this. So A star B. So what is value for A star B? That is greatest lower bound of A and B. So here greatest lower bound is A. So that we have written here and RHS is B star A. So again we have to take greatest lower bound of B and A and that is A. So here LHS is equals to RHS. So first statement is true. So likewise we can do this for second operation and that is join operation. That is A XOR B is equals to B XOR A. So look at this diagram. A XOR B. What is meaning of this join operation? We have to consider least upper bound of A and B. So here least upper bound is B. Okay. So LHS is B and now RHS is B XOR A. So again B XOR A. So again we have to consider least upper bound of B and A. It is B only. So again B is equals to B. So in this way, we have proved that lattice satisfies commutative property. Already last lecture we have seen all these proofs. Once again I am repeating here. Now second property is associative property. So for this associative property, we have to consider any three elements. Those belongs to L. Now these three elements are A, B, C, and all these elements belongs to lattice L. So they are represented here by using this diagram. So how we can prove for this associative property? First, consider neat operation. So A star, B star, C. This is LHS, and RHS we can take in bracket A star B star C. Okay. So every time, first of all, we have to solve this bracket. So B star C, value for B star C. So greatest lower bound of B and C, and its value is B. Now we have to take A star B. So greatest lower bound of A and B, it is A. Now move towards the RHS. So first of all, we have to solve this bracket as A star B, and value for this one is A, that is written here, star C. So again, greatest lower bound of A and C, and it is A. So that is written. So in this way we can prove for associative property. That is, lattice satisfies associative property. So whatever properties we have mentioned for lattice as algebraic system, first we have proved for commutative, second one is for associative. Now we have to prove for absorption law. That is, lattice satisfies absorption law. So here absorption law is written, that is A star in bracket A XOR B, that is equals to A. So now first again we will check for this bracket A XOR B. Means what? Least upper bound of A and B. And what is this least upper bound of A and B? It is B. So that is written here. Again A star B. Means what? Greatest to lower bound of A and B, and that value is A. So here we have written A. So again LHS is equals to RHS. That's why this statement is true. Now similarly we can check for join operation. That is A XOR A star B, that is equals to A. So value for A star B, that is greatest to lower bound of A and B, it is A. AX or A, again it is A. So here also we have to, these statements are correct. So for this statement, that is lattice as an algebraic system, they have asked you question for 4 marks. Write a short note on lattice as an algebraic system. At that time, you have to write the lattice satisfies three properties: commutative, associative, and absorption law. And you have to write explanation for each of these properties. Then only you will get full marks. So, have you understood this point? Whatever properties we have seen in the last lecture, same properties are here. Nothing is different. Somerset?
Yes,
Yes,
ma'am.
ma'am.
Okay. Now, here one question is given as recognize whether following diagrams are lattices. In the first lecture only, we have seen how to check whether given diagram is lattice or not. Now look at these diagrams and tell me whether these are lattices or not. So first of all, consider diagram 1, first diagram, and tell me whether this is lattice. Before that, just tell me how to recognize whether given diagram is lattice or not. What is the condition to be a lattice? Yes.
For any pair, there is present the greatest lower bound and least upper bound.
upper. Yes, correct. So for every diagram or for every pair of elements, there should be greatest lower bound and least upper bound. Now check for the first diagram whether this condition is true.
Yes.
Yes, that's why this is a lattice. So for this diagram, if you consider pair of elements B and C, okay. So what is the greatest lower bound for these two elements?
A.
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 And least upper bound?
D.
D.
D. Yes, correct. That's why this is a lattice. Now check for second diagram whether this one is a lattice.
No.
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 Why?
For pair A and B, there is not present greatest lower bound.
Is correct. For A and B, there is no any greatest lower bound. And if you consider pair of elements E and F, then there is no least upper bound. That's why this is not a lattice. Now check for third diagram.
Lattice.
Lattice. How? Okay.
For every pair, there is present.
Now consider pair of elements E and D and tell me for this pair which one is greatest lower bound and which one is least upper bound. Can we define it? So there exists two greatest lower bonds for E and D, and these two are elements as B and C. Okay, B and C. These are two greatest lower bonds, but there is no any least upper bond for these two elements. That's why this is not a lattice. And in order to be a lattice, there should be only one greatest lower bond and least upper bond. But this is not the case with this third diagram. That's why this is not a lattice. Are you getting it?
Yes,
Yes,
ma'am.
ma'am.
Okay. Now check for this next diagram whether this one is lattice.
No,
No.
ma'am.
Why? Yes,
For all
why?
the pair B, comma C,
B
two
comma C.
least upper bound are present.
Two upper bonds are present. What are those?
D and E.
It's D and E. That's why this is not a lattice. Correct. So in this way we can recognize for a lattice. Okay. So now we have to see the next point, and that is sublattices, direct product and homomorphism. So I think from algebraic systems onwards we have seen what is subsystem of given system like monoid, submonoid, semigroup, subsemigroup. Likewise, now we have to define for lattice and sublattice. Lattice we have seen. So now we have to define sublattice. So let L star XOR be a lattice and let S is a subset of L. The algebra S star XOR is a sublattice of L star XOR if and only if S is closed under both operations star and XOR. So, suppose there is one lattice L star XOR. So, what is meaning of this system L star XOR? So, L, this is a lattice, and star and XOR, these are the two binary operations. Those are defined on L. Now, consider another set F, and that is subset of L. S आता है also subset and now S is closed under operations star and XOR. Then S star XOR is called as sublattice of L star XOR. So this is the definition for sublattice. So just keep in mind that if L is lattice and S is another set, then in order to be S as a sublattice of L, S must satisfy two properties. First one, S should be subset of L, first important condition. And second one, S should be closed under operations star and XOR. Then only we can say that S star XOR, this is sublattice of L star XOR. Are you getting this definition? इझी आहे फक्त तो एस हा एल चा सबसेट पाहिजे आणि परत एस हा क्लोज पाहिजे कुठल्या ऑपरेशन साठी स्टार अँड एक्सओर ओनली दीज टू कंडिशन्स वी हॅव टू सॅटिस्फाय देन ओनली एस इज कॉल्ड एज सबलॅटिस ऑफ एल समजली का डेफिनेशन we have seen what is meaning of closure property in the unit number 6. So what is closure property? We have seen many examples on this. Closure property म्हणजे काय? आहे का लक्षात काही? Closure means what?
If we perform given operation on given set, then
Okay.
that element belongs to given set.
Yes. So if you perform any operation on any two elements from that set, whatever result we will get, that result should be part of that set. Then only we can say that it is closed under that operation. So if you consider S as a set of elements and these are two operations star and XOR. Now if you want to check whether S is closed under these two operations or not, we can consider any two elements from this set S and we can perform either star or XOR operation on these two elements. Then whatever result we will get, that result should be a part of this set S. Then only we can say that S is closed under operation star and XOR. Okay. Yes, that condition is correct. Now here one example is given. From that, we have to recognize what are the sublattices of given lattice. Okay. So let L partially ordered set be a lattice in which L is equals to A1, A2 dash dash up to A8. So L is consists of total 8 elements A1, A2, A3, A4, A5, A6, A7 and A8. So those are defined from A1 to A8 and S1, S2, S3, these are subsets of L, and these subsets are given as S1 is equals to A1, A2, A4, A6, S2 is equals to A3, A5, A7, A8, and S3 is equals to A1, A2, A4, A8. Okay. So three subsets are defined out of this L, and those subsets are S1, S2, and S3. Then diagram of L partially ordered relation is given in figure. So this is given lattice. So here S1, S2, and S3. These are lattices or not, we have to check. Okay. काय केले त्यांनी? Just they have given one lattice which is consist of total 8 elements from A1 to A2. Sorry, A1 to A8, and three sets are given: S1, S2, S3. Elements are mentioned here. So from this we have to recognize whether S1, S2, and S3 are sublattices of given lattice or not. Okay. So first I will tell you how to check whether a given lattice is sublattice or not. So for that, first consider first set as S1. So what are the elements of S1? A1, A2, A4, A6. Okay. Now we have seen in the definition of sublattice, in order to be a sublattice, it should be closed under operation star and XOR. So now we have to apply these two operations on set S1. Then only we can say that whether this one is sublattice or not. Now check in this diagram, A1 is located here, next element A2 is here, A4 is here, and A6 is here. Okay. So we have to recognize this rectangle. Okay. A1, A2, A4, A6. So now apply greatest to lower bound and least upper bound on any two elements of this set S1. So consider pair of elements A1, A2. So if you take these two elements A1, A2, greatest to lower bound for this pair is A2 and least upper bound is A1. Now consider pair of elements A2, A4. So this is A2, this one is A4. So for this pair, greatest to lower bound is A6 and least upper bound is A1. Now A1 and A6, this is the result we got after performing meet and join operation on these two elements, and that result, that is A1 and A6, that is present in given set S1. Now check for another pair of elements, that is A4 and A6. So if you check for A4 and A6, then greatest to lower bound for this pair is A6 and least upper bound is A4. So again, whatever result we got, that is A6 and A4, both are present in this set S1. So we can say that after performing meet and join operation on any pair of elements from this set S1, whatever result we got, that result is present in S1 only. That's why we can say that S1 is closed under operations meet and join. That's why S1 is sublattice of given lattice. So in this way we can check. So just let me know whether you have understood this, how S1 is sublattice of given lattice. Hello? Yes, what happened? Understood or not? Shall I repeat this once again?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So here this is the given lattice, and out of this lattice they have defined three subsets S1, S2, S3. Now why these are called as subsets? Because S1 is containing S2 and S3. All these are containing the elements. Those are parts of this given lattice. So if you observe S1, S1 is containing A1, A2, A4, A6, and all those elements are present in this given lattice. So we can say that this is, that is S1 is subset of L. Okay. So this first property we have satisfied. Now we have to check whether S1 is closed under star and XOR operation. If it is closed, then we can say that S1 is sublattice of given lattice. Okay. So how to check whether this one is closed under those two operations or not? So for that purpose, we have to consider any pair of these elements. So if you consider A1, A2, now look here, A1 is located here, A2 is here. Now perform meet and join operation on these two elements. Meet operation means what? Greatest to lower bound. So for this pair of elements, greatest to lower bound is A2 and least upper bound is A1. So after performing these two operations, that is meet and join operation on these two elements, we have got A2 and A1 as a result. Now check whether this result is present in S1. So S1 is containing A1, A2. Yes, that is fine. So after performing meet and join operation on pair of elements A1, A2, whatever result we got, that is present in S1. Okay. Up till now, is it fine? इथपर्यंत समजले का?
Yes, ma'am.
Okay. Now check for another pair of elements. We have checked for A1, A2. Now we can consider another pair of elements. Consider A2, A4. Okay. So A2 is here, A4 is here. Now perform meet and join operation. That is star and XOR operation on these two elements. So what is value for A2 star A4? Star operation means what? Greatest to lower bound. So what is the greatest to lower bound here? A6. Correct. And least upper bound?
A1.
A1.
A1. Okay. So what result we got? A6 and A1. Now check whether A6 and A1 are present here in S1. Yes. Those are present here. Okay. Now consider another pair of elements. If you consider A4 and A6, A4 and A6. So what is the greatest to lower bound here? Yes. Time array greatest to lower bound.
A6.
A6 and least upper bound A4. So again,
A4.
yes. So again we can check whether A4 and A6, that result is present in S1. Yes, A4 and A6 are here. So we can say that if you perform star and XOR operation or meet and join operation on any two elements of this set, whatever result we will get, that result is present in this set S1. So S1 is called as sublattice of given lattice. जे काही रिझल्ट सगळे आपल्याला मिळाले ते सगळे रिझल्ट S1 मध्ये आहेत. So we can say that S1 is closed under operation star and XOR. That's why S1 is sublattice of given lattice. Are you getting now?
Yes, ma'am.
Okay. So now check for S2 whether S2 partial ordered relation is a sublattice of given lattice. So S2 is consist of elements A3, A5, A7, A8. A3, A5, A7, A8. So this part only you have to consider and you have to check whether this one is sublattice of given lattice. Think on it and tell me whether this one is sublattice. Yes? Is it sublattice?
Yes, ma'am.
Okay. So what pair of elements you have checked?
A5, A3 is
Okay. So if you consider this pair of element A5 and A7, so what is greatest to lower bond here?
8,
A8 and least upper bond
A3.
A3. Okay. So now check whether A3, A8 are a part of this S2, A3, A8. Okay. These are
Yes,
present.
ma'am.
So again, if you consider A3, A5, A3, A7, that result of meet and join operation that is present here in S2. So we can say that S2 is closed under meet and join operation. So S2 is sublattice of given lattice. Okay. Now consider S3 and S3 is consists of A1, A2, A4 and A8. A1, A2, A4 and A8. So now check whether S3 is sublattice. Take time of 2 minutes and think on it whether this one is sublattice. Hello? Whether S3 is sublattice? What is your answer? Hello. Okay, we will check here. S3 is consist of elements A1, A2, A4 and A8. Now we can consider any pair of elements from this side. So consider pair of elements A2 and A4. Now perform meet and join operation on these two elements. So what is answer for meet operation? That is A2 star A4. Answer क्या है?
A6.
A6. A6.
A6.
Now check whether that element is present here in S3. No. So we can say that after performing meet and join operation, that result, that is A2 star A4, is A6 and that element is not present in S3. That's why S3 is a lattice. S3 is a lattice, but this is not a sublattice. हाँ, lattice आहे, but it is not a sublattice. So out of this, only S1 and S2 are sublattices of given lattice, but S3 is not. So have you understood concept of sublattice?
Yes, sir.
Okay. Good. Now next point is direct product. So here before we have seen direct product for which concept? Direct product of algebraic system. So now we have to check for direct product of lattices. So definition is given here. Let L star XOR and S and OR be two lattices. Okay. Here two lattices are defined as L and S, and star and XOR. These are two binary operations on L, and OR. These are two binary operations on S. Then the algebraic system L, this is symbol for direct product. L direct product is then dot and plus. So what is the meaning of these two operations? So after performing direct product on these two systems, whatever result we will get, and that is represented here by dot and plus. So in which binary operations plus and dot on L direct product S are such that for any two elements, or we can say for any two order pairs A1 A2 and A2 B2, sorry, A1 B1 and A2 B2 in L direct product S is defined as, so here first we have to consider operation as dot operation A1 B1 dot A2 B2. So if you consider any two pairs A1 B1 A2 B2, and if you perform dot operation on them, then you will get a result as A1 star A2, and next one B1 and B2. Now, if you consider this plus operation on A1 B1 A2 B2, then A1 B1 plus A2 B2, this is equals to A1 XOR A2, comma B1 or B2. Then this is called as direct product of these two lattices. So this is the definition. Now we will see how this direct product has calculated. So L and S, these are the two lattices, and now we have to take direct product. Direct product म्हणजे काय? It is just like multiplication, and that is written here by L direct product S. So if you consider any two set of elements like A1, B1, A2, B2, and if we perform star operation on them, this dot operation on them, you will get elements, those will contain star and operation. Why? Because meaning of star and dot. So meaning of these three operations is same. In the first lecture only we have seen what are the alternative symbols for join and meet operation. So for this meet operation, there are three symbols. First one is star, second one is and, or we can say conjunction, and last one is dot. So likewise for join operation, again there are three alternative symbols. First one is XOR, second one is OR, and third one is plus. So if you perform dot operation on these two order pairs, you will get a result that will contain either star or and. So this result is shown as here A1 star A2. This is the first result, comma B1 and B2. ठीक आहे. जर तुम्ही डॉट ऑपरेशन परफॉर्म केला तर तुम्हाला हे दोन ऑपरेशन ऍज अ रिझल्ट मिळतील. A1, A2, these are the elements of first set. And what is the first operation we performed here? That is star operation. That's why A1 star A2 we will get. Again, this AND operation is defined for second set. And B1, B2, these are the elements of second set. So, B1 and B2. So, likewise, if you consider this plus operation, so A1, B1 plus A2, B2. Okay. So, first of all, A1, A2, these are the elements of first set. And for this set, what is the alternative operation of plus? Plus साठी alternative operation कुठला इथं XOR. So result we will get that is A1 XOR A2 and B1 B2. These are the elements of this second set, and in that alternative operation for this plus is OR. So this result is B1 or B2. So this is the direct product of L and S. Are you getting this definition? Hello? समझते का? Yes.
Can you repeat?
So here two lattices are defined. First one is L, and on this L two operations are defined, star and XOR. Second lattice is S, and on this lattice two operations are defined and an OR. Okay. So these are two lattices. Now we have to take direct product between these two lattices, and that direct product is represented here by L. This cross symbol is for direct product, L direct product S. And after performing this direct product, we will get operations as dot and plus. Okay. Now, if you consider these three lattices, then we can say that this star and dot, these three operations are having same meaning, and XOR, OR and plus, these are having same meaning. आपण फर्स्ट लेक्चर मध्येच बघितलंय, ग्रेटेस्ट लोअर बॉन्ड रिप्रेझेंट करण्यासाठी we can use either star operation or AND operation or dot operation. So likewise, to represent least upper bound, we can use XOR operation or OR operation or plus operation. So meaning of these symbols is same. Now, if you consider any two pair of elements A1, B1, A2, B2, those are present in direct product of L and S. Then how we can perform this dot and plus operation on them? So consider pair of elements a1 v1 dot a2 v2. So this is dot operation. The dot operation म्हणजे काय? It is similar to star operation and operation. So now consider a1 a2 direct product of a1 a2. So a1 a2 belongs to this first set L. Now for this set, what is the operation we have defined for this dot? Dot's similar operation कुठला आहे? Star operation. So for this a1 a2 we will write direct product as a1 star a2. Now b1 b2 these are the elements of set S, and for this set S we have defined AND operation that is similar to dot operation. That dot operation was similar operation कुठला आहे? Set S that is AND operation. So we will write here b1 and b2. So likewise, if you consider this plus operation, so plus operation, if you define on a1 b1 a2 b2, then you will get a1 XOR a2. Why? Because a1 a2 these are elements of first set, that is of set L, and for this set L there is XOR operation which is similar to plus operation. So we have written here a1 XOR a2. So now if you check for second set, so b1 b2 these are the elements of set S, and in this set S there is operation that is OR operation which is similar to plus operation. That's why we have written here b1 or b2. So this is called as, that is L star S, L cross S is called as direct product of these two lattices. समजलं का? डायरेक्ट प्रोडक्ट कसा डिफाइन करायचे? Okay.
Yes, ma'am.
So most of time they have asked this definition for 2 marks, right? Definition of direct product, or they will ask you question like explain the following terms with respect to lattice. In that they may have given sublattice, direct product and homomorphism. So this question will be for 6 marks. So you have to explain each of these terms for 2 marks. Now we have to see why we have to take direct product. See, direct product कशासाठी घ्यायचं आहे? Because suppose L is a lattice and which is containing just 2 elements. Now suppose we want to form a larger lattice from this lattice. L पासून आपल्याला एक bigger lattice तयार करायचे. तर त्यासाठी काय करावं लागेल? We can take direct product of L with L. That is L direct product L, and it will give you L2. Okay. So likewise again we can extend it or expand it by taking L direct product L direct product L. So L3. म्हणजे काय L हा जर छोटा लॅटिस असेल आणि त्याच्यापासून तुम्हाला लार्ज सेटचे लॅटिस कन्स्ट्रक्ट करायचे असतील, at that time you can take direct product as L2, that is L square, L cube. Likewise L square means what? L direct product L. L3 means what? That is L raised to cube means what? L into L into L. So likewise we can form a bigger lattices. So here they have given one example in order to explain the need of direct product. So let L is equals to 0, 1 and lattice L partial ordered relation as shown in figure. In short, this is the given lattice, and which is consist of 2 elements 0 and 1. Then lattices L square this operation is defined on it, that is defined here, and L cube, that is shown here. So these are the lattices, those are formed after taking direct product. Now see here, L मध्ये किती element आहेत? 2 element आहेत. तर L square मध्ये किती elements असणार आहेत? L into L, म्हणजे काय 2 into 2, because L is consist of 2 elements. So 2 into 2, that is equals to 4, and those 4 elements are given here. So first element is 0, 0, second one 0, 1, third one 1, 0, and last one 1, 1. So here we have formed larger lattice from original lattice L. So this is L, second one is L square. Now suppose we want to form L cube. आता L cube घेतला तर elements किती येतील L cube मध्ये? L into L into L, and L is consist of 2 elements. So L cube will consist of how many elements?
8 elements.
8 elements, correct. And those 8 elements are represented here like 0, 0, 0, 0, 0, 1, then 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, and triple 1. So these are the 8 elements we have formed from these 2 elements 0 and 1. So in this order we can form or we can construct larger lattices from smaller ones. So this is the advantage of direct product. Okay. They have never asked any question regarding this one, but still I am explaining you what is need of direct product. समजलं का? How we can form larger lattices? Just we have to take direct product between lattices. Okay. So next diagram is given. For this example, you have to try. Here, 2 lattices are given, L1 and L2. L1 is consist of 1, 2, 4, and L2 is consist of set of elements 1, 3, 9. Then you have to draw a lattice for L1 direct product L2. Okay. So before that, first of all, tell me how many elements would be there in L1 direct product L2. Elements किती असणार आहेत? Previous example मध्ये आपण बघितले. If your set L is consist of 2 elements, then L square that will consist of 4 elements because 2 into 2 4, and L cube will consist of 8 elements as 2 into 2 into 2. So if your first set L1 is consist of 3 elements and L2 is consist of 3 elements, then direct product of these two lattices L1 direct product L2 will consist of how many elements?
9.
9 elements. That is 3 into 3, 9. Okay. So now you have to draw lattice for L1 direct product L2. Take time of 5 minutes and try to solve this. If you are not able to solve this, then I will explain. But before that, you have to try. Just keep this example in your mind, how we have formed L square and L cube from L. So likewise, here L1 and L2 are given, and from that you have to construct L1 direct product L2. Hello? Have you tried for this example? Okay. So just let me know what are different 9 elements will be there. Yes, what are those elements? That is so simple. If you consider first element from this L1 as 1, then we can take 1 into 1, that is answer is 1. Again 1 into 3, it is 3. 1 into 9, it is 9. Okay. So again we can take second element 2 into 1, 2, 2 into 3, 6, and 2 into 9, 18. Then 4 into 1, 4, 4 into 3, 12, 4 into 9, 36. So likewise, we can define a elements of lattices. Now here we can represent as 1 comma 1 or 1 into 1, answer is 1. एकतर तुम्ही असे ऑर्डर पेअर लिहू शकता or you can write whatever result we will get after direct product. So 1 comma 1 is what? 1 direct product 1. Answer is 1. Then 1 comma 3. So for this order pair, answer is 3. 1 comma 9, it is 9. So Again, for second element 2, we can write elements like 2, 1, 2, 3, 2, 9. And for 4, we can write 4, 1, 4, 3 and 4, 9. So in this way, we can construct a direct product lattice. डायग्राम समजली का कशी ड्रॉ केली
हे प्रोडक्ट कंपल्सरी लिहायचे का
हे प्रोडक्ट का ब्रॅकेट मधले Yes, there are two different ways. Either you can represent that product as 1, 1 or you can write answer as 1. Same 1, 3 or 3. एक तर ऑर्डर पेयर लिया किंवा तसा डायरेक्ट प्रोडक्ट लिया. Both the ways are correct.
Okay.
Okay. Okay. Now next definition is for homomorphism, and we have repeated this definition of homomorphism for many times. That is homomorphism of semi-group, monoids, groups, and now we are going to define homomorphism for lattice. So let L star XOR and S and OR, these are two lattices. Then a mapping G from L to S is called as lattice homomorphism from lattice L star XOR to S and OR if any AB belongs to L. So here just two lattices are given, L and S, and mapping G is given from L to S. Then this mapping is called as lattice homomorphism if you take any two elements A and B, those belongs to L, G of A star B is equals to G of A and G of B, and G of A XOR B is equals to G of A or G of B. So what you understood from this definition? How we have written these two statements? हे असंच का लिहिलं आपण? सगळ्या डेफिनेशन मध्ये आपण सेम कन्सेप्ट अप्लाय केली. If you apply function g on A star B togetherly, then we can write as g of A star B. Now, if you want to apply this function g separately on A and B, at that time you have to consider similar operation of star from next set. So here, for this star, there is similar operation is AND. So, G of A and G of B. जर तुम्हाला हे ऑपरेशन G सेपरेटली परफॉर्म करायचं असेल तर तुम्हाला नेक्स्ट सबसेट मध्ये और नेक्स्ट लॅटिस मध्ये कुठलं ऑपरेशन सिमिलर आहे ते लिहावं लागेल. दॅट इज G of A and G of B. So likewise, we can perform this XOR operation on A and B as G of A XOR B. Now, if you want to write this separately, then we can take G of A. Now, check here for this XOR operation, which one is the similar operation? That is OR operation. So, G of A XOR B is equals to G of A or G of B. So, in this way, we can define lattice homomorphism. Have you understood this definition? समझने का definition? Okay. So here two lattices are given. L star XOR, this is the first lattice. S and OR, this is the second lattice. Now, if you observe these two lattices, we can say that star operation is similar to AND operation and and this XOR operation is similar to OR operation. Okay. Now, a mapping G is defined from L to S. Okay. Mapping means what? A function. Function is defined from L to S. Then that function is called as lattice homomorphism if for any two elements A and B belongs to L, G of A star B is equals to G of A and G of B. So how we have written this statement? A and B हे कोणाचे element आहेत? Set L चे element आहे. Now suppose we want to apply this function G on them. Then we can consider first operation from this lattice L as star operation. So now apply this star operation on these two elements as A star B. Now we have to apply this function G on that A star B. So that is written here G of A star B. Now suppose we want to apply this function G separately on element A and element B. Then at that time we can take G of A, G of B separately, and on these two elements we can perform AND operation. AND operation is why we can't write here OR operation? Because this AND operation is associated with this star operation. Star and answer meaning same thing. That's why we have to take this second operation from second lattice because this is similar to star operation. So we can write G of A star B is equals to G of A and G of B. So likewise, if you want to define or apply this XOR operation on two elements A and B, then that operation will be A XOR B. Now suppose you want to apply this function G on that set as G of A XOR B, then this is similar to G of A. Now check which one is similar operation for this XOR. That operation is OR. So G of A or G of B. So this is called as lattice homomorphism. ही definition सेमच आहे. जसं आपण homomorphism for algebraic system define केलं, just like homomorphism of semigroup, group and monad. सेमच concept आहे. जर तुम्ही function G एकत्र apply केला, then no problem. Then if you want to apply this operation separately, at that time you have to consider similar operation from next algebraic system. And here that second algebraic system is S and OR. That's why if you want to apply this star operation separately, then you have to consider AND operation. If you want to apply this XOR operation separately, at that time you have to consider OR operation. समझ का definition?
Yes, ma'am.
Okay. Now we have to define isomorphism, endomorphism and automorphism. लक्षात आहे का काय? What is meaning of isomorphism? Iso means what? Both. If that function is both one to one and on to, then that is called as isomorphism. So if a homomorphism G from L to S of two lattices L star XOR and S and OR is bijective. Bijective means what? If it is one to one on to, then function G is called as isomorphism. So in short, we can say that if this function G is one to one on to, then that is called as isomorphism. Meaning समजलं का? Isomorphism का म्हटलंय? Because this function is both one to one and on to. That's why this is called as isomorphism. Okay. So again, if there exists an isomorphism between two lattices, then those two lattices are called as isomorphic. Okay? जर त्या दोन lattices मध्ये isomorphism असेल, then those two lattices are called as isomorphic to each other. Now, next definition is given for endomorphism. So, a homomorphism G from L to L, where L is L star XOR is a lattice, is called as is called as endomorphism. Okay? जर homomorphism define केला G from L to L, that homomorphism is called as endomorphism. And if G from L to L is an isomorphism, then G is called as automorphism. Okay. So these are two definitions for endomorphism and automorphism. जर homomorphism define केलं असेल, then that is called as endomorphism. If that function G is isomorphic, then that is called as automorphism. So just you have to keep in mind, homomorphism is related to endomorphism and isomorphism is related to automorphism. हे जर तुम्हाला pairing लक्षात राहिलं, then you can write definition correctly. Isomorphism म्हणजे काय आहे? If that function G is both one-to-one and on-to, then homomorphism G is called as isomorphism. Okay. And next definition of endomorphism. If homomorphism G is defined from L to L, then that G is called as endomorphism. And for automorphism, if that function G is isomorphism, isomorphic function असेल, then G is called as automorphism. Definition समजले का? फक्त keywords लक्षात ठेवायचे तुम्हाला. Hello? Okay, we will revise it. What is isomorphism? Isomorphism तरी असणार आहे. Isomorphism one to one onto a self function G, then that is called as isomorphism. Endomorphism कधी असणार आहे? If there is
Homomorphism of G.
if there is homomorphism from L to L, then function G is called as endomorphism. And automorphism, if function G is isomorphic,
Homomorphism of G.
yes, if function G is isomorphic from L to L, then G is called as automorphism. So here they have given one diagram that shows how we can draw lattice of any order. So here they have considered order of 5. So what is meaning of order of 5? It will consist of 5 elements. So observe this 1, 2, 3, 4, 5. So first diagram is consist of 5 elements. So we can say that it is lattice of order 5. So likewise, second, third, fourth, and fifth. All these lattices are containing only 5 elements. That's why this is called as lattices of order 5. Now here they have given one example. Consider lattice S12D. So S12, 12, this is an integer number. D means what? Divides relation. So you have to draw lattice for this set S12. जसं आपण बघितले लास्ट लेक्चर मध्ये we have drawn lattices for S6, S36, S18. So likewise here you have to draw lattice for S12. So first of all tell me what are the divisors of 12? Because those will be
1, 2, 3.
1, 2, 3, 4, 6 and 12. Okay. So there are 6 elements. So can you draw lattice for this one?
Yes, ma'am.
Okay. Try it and post your answer on group or personally to me on WhatsApp. I got answer from Rutuja. That is correct. So there are total 6 elements 1, 2, 3, 6, 4 and 12. Okay. So we can draw lattice like this as 1 divides 2, 1 divides 3 and both 2 and 3 divide 6. Again 2 divides 4 and 4 and 6 divides 12. So this is the correct lattice for S12 and if that relation is divides relation. Good. Nice attempt. Okay. So today we will stop here. Remaining points we will see next lecture. So just let me know, do you have any doubt regarding today's points? सगळे पॉइंट समज yes?
No, ma'am.
Yes, you can speak.
No problem, ma'am.
Good. So just give me presenting. Roll number 1,
Yes, ma'am.
2,
Yes, ma'am.
3,
Yes, ma'am.
4,
Yes, ma'am.
5. Roll number 5, 6, 7,
Present, ma'am.
8, 9,
Yes, ma'am.
10,
Present, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
13, 14, 15, 16, 17, 18,
Present, ma'am.
19,
Present, ma'am.
20, 21, 22,
Present, ma'am.
23,
Present, ma'am.
24,
Yes, ma'am.
25, 26,
Present, ma'am.
27,
Present, ma'am.
28, 29,
Yes, ma'am.
30,
Present, ma'am.
31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34, 36,
Present, ma'am.
35, 36,
Yes, ma'am.
37,
36 present.
okay, 37, present, 38,
Present, ma'am.
39,
Yes, ma'am.
40,
Present, ma'am.
41, 42,
Yes, ma'am.
43,
Present, ma'am.
44, 45,
Yes, ma'am.
46, 47, 48, 49, 50, 51,
Present, ma'am.
52, 53, 54, present, okay, 55,
Yes, ma'am.
56, 57,
Yes, ma'am.
58,
Yes, ma'am.
59, 60, 61, 62,
Present, ma'am. 62 present.
63, okay,
Present, ma'am.
64,
Present, ma'am.
65, 66, 67,
Present, ma'am.
68,
Present, ma'am.
69, 70. So today, so many students are absent. Check for absent numbers. Roll number 5, 6, 8, 13, 14, 15, 16, 17, 20, 21, 25, 28, 34, 35, 41, 44, 46, 47,
Madam,
48,
46.
present.
46.
Okay. 48, 49, 50, 52, 53, 56, 59, 60, 61, 65, 66, 69, and 70.
Ma'am, 66 is present.
Okay.
Ma'am, 22 is present.
22. Okay.
Ma'am, 67.
67. Yes, I have marked present. Okay. So we will stop here. Thank you.
Hello, ma'am.
Hello? Yes?
Can you send PDF of this lecture?
Yes,
That
yes.
chapter?
Yes, I will send today only.